Welcome everybody out to podcast number 329. Are you creating steadiness and flow? Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome everybody. I just want to say hi to you. Today I won't have a lot of the scaffolding that I normally have in the podcast because, quite frankly, I'm in a little bit of a rush, but I'm headed off to work with a fantastic client, and I just finished this morning the final writing in the Elevating Construction Takt Planning book, edition number 2. I think we're going to retitle that Takt Planning and Integrated Control. But that second edition is in full editing. I'm hoping to have that out, and quite frankly, hopefully on Kindle and Amazon, probably 2 weeks. So cheer me on, pray for me, all the good stuff. So I'm going to read to you today one of the sections from the Elevating Construction Superintendents book. It's Principle 2, Steadiness and Flow, because it's on my mind right now, and we really have to get a consensus among builders on how to work within a takted system. So I'm going to read this to you. This is a little bit different. I'll have a brand new, beautiful podcast for you tomorrow, but today's going to be the reading of this section. So let's see if I can get through it without making any mistakes and win. So the following is an excerpt from the book, Elevating Construction Superintendents. We reference it here because it communicates nicely how a superintendent should interact with Takt planning. So here we go. There is a popular game used to teach lean construction management called Parade of Trades. 7 participants sit together around a table. Each one represents a contractor for a different scope: concrete, steel, facade, and so on. There are 35 chips on the table that represent 35 pieces of work that must be completed to finish the project. The goal is to pass all these chips through to the last contractor as quickly as possible to simulate the completion of the work on the project. To complete their work, players roll a die and pass that number of chips to the person next to them. If someone rolls a 6 but only has 1 chip at their station, they can only send 1 chip forward. If they have 6 chips and roll a 1, they can only move 1 chip. When everyone has rolled, that represents 1 week of work, and the process is repeated for as many weeks necessary to move all the chips to the end. Often this game is played with different teams competing with each other to be the team to finish their work in the fewest number of weeks. Let's say that at one event, the red team got all 35 chips to the end in 26 turns. When you tally the number of workers on site, you get 380. The maximum material inventory at any one location was 10. So in 26 weeks, the red team moved 35 units of work down the line with 380 people and a material inventory level of 10 units per week. Pretty good. How did the blue team do? They completed the work in 21 weeks with 280 people and a maximum material inventory buildup of just 5 in a given week. That means the blue team was 5 weeks ahead of schedule with 100 fewer people on site and half the material on site. How did they manage that? The tricky secret is that the red team had a regular 6-sided die with numbers ranging from 1 to 6. The blue team had a die that could only roll 4s, 3s, and 2s. A week in the normal die would be something like 6, 5, 5, 2, 2, 1, 1, and would represent an attempt to move quickly at first, followed by a slowdown because of an interruption, and eventually ending up stuck. A week with the blue team's die might look like 4, 4, 3, 4, 3, 2, 2. This is synonymous with the concept of maintaining the flow of work. A flow has very little variation. When that variation is eliminated, the chips, or the work, could flow from one end to another without getting held up by the overwhelming rush from rolling a 6 or the painful crawl of a 1. What is the lesson here? Before making that explicit, let's reflect on the current state of our industry. We often hear people say, we need to get out of the ground fast when we can influence a fewer number of contractors. This is correct. We also hear that we need to be aggressive with complex and unknown areas and scopes on our projects. This is also correct. Sometimes, though, well-meaning folks will apply both of those concepts to the entire project and say things like, advance the schedule whenever possible, or I want all my materials here now, or just bring it, or I am a pusher, or keep pushing everything you can for the schedule. These people are trying to roll sixes in the parade of trades, which will later cause a mess of ones. Consider this. What if we told a superintendent to slow down a little and keep a steady flow and an even pace? What would he say? He might say we know absolutely nothing about construction and should go get another job. And yet, the data shows he will finish in 26 weeks with 380 people on site with a material inventory of 10. Like the red team in parade of trades. This happens because people think movement equals production, which is not the case. All this movement is actually a waste. People start pushing and creating variation because it makes them feel good. It gives an impression of progress, but it requires twice as much material, 100 more people, and 5 more units of material inventory in a week. What happens when a superintendent won't keep a flow in the schedule and hold dates? If you're a trade partner, how would you react? You would possibly keep more people on site and most definitely keep more materials on site. What happens when materials pile up on site? You guessed it, production slows down. Everything slows down because part of our workforce is dedicated to managing, moving, inventorying, fixing, replacing, reordering, and organizing materials. Here is an example. Imagine a factory with an assembly line that produces a certain number of finished items every hour. The throughput is the rate at which the factory can process the raw materials into finished items. Say you have 4 machines in the factory that work together to produce the final finished product. Items need to be moved from one machine to the next for that machine to do its part in the process. The first machine can work on 4 items per hour, the second at 2 items per hour, and both the third and fourth machines produce 4 items per hour. What is the throughput of the system per hour? Did you say 2? Okay, let's go with that. Now, what could we do to get all machines working at the same rate? Speed up the 2-part machine per hour? That is correct. We can either add another machine or replace it with a faster one. What would the throughput of this system be then? Did you say 4? That is correct. But what if we did not speed up the 2-part per hour machine? What else could be done to get everyone working in the same rate? Yes, that is correct. We could slow down the 4s and get everyone working at a throughput of 4 parts per hour. Now here's the moment. You said the throughput of the first example where we had all machines working at full efficiency, even though they were going different speeds, was 2. This may surprise you, but it's likely going to be 1.25 or 1.5 finished items per hour. Consider what happens between the first and second machines. An inventory of materials begins to pile up. Manpower is then allocated to manage the material inventory. Space in the factory diminishes. People who would otherwise be running machines are now managing the machines and the material inventory. Workers down the line are waiting, and more resources are needed to manage materials on the third and fourth machines. Waste increases and the speed of the system decreases. Therefore, the throughput of 1.5 or fewer finished items per hour instead of 2. That is the throughput. They would have been better off to increase the 2-part per hour machine to a 4-part per hour machine or slow everything down to 2. That would at least have a throughput of 2 parts per hour. When anyone on site says work everywhere at full efficiency or keep pushing or bring all materials here now or don't slow down anything or I want workers working everywhere on site with no empty areas, all they are doing is slowing down the speed of production by increasing material inventory and creating a lot of wasted jobs for people who would otherwise not be needed on that site. Why? Because we needed flow and what we got was variation. If this was the parade of trades, we needed to roll consistent 3s and 4s instead of 6s and 1s. The answer is not to push all the time. The ideal is somewhere in between. Anything on site that can be made to flow should. If we are coming out of the ground or have a complex area on site with high-risk unknowns, those may be good reasons to accelerate. The point is that pushing comes at a risk, and flow will always reduce materials, manpower, mistakes, and the time it takes to do something. So if you can create flow, do it. If you must pull an area, know the consequences and do it only if you must put work in place early to vet mistakes early. But for no reason should you push on site and create variation. Don't roll 6s and 1s when you can roll 3s. The art of attack means artfully taking advantage of opportunities to plan, prepare, and move strategically. If you hear someone ask to create variation in schedules and flow, be skeptical. If you hear folks ask for an increase in material inventory, give it a second look. We want to create stable environments, keep workers installing the work they plan for the day or week, and have a plan for everything. The important reflection for this is the cost associated with it as well. If you compare just in this little example the cost difference between the red team and the blue team, you get the following. 26 weeks with 380 workers is 380 people at $55 per hour at 40 hours a week at 26 weeks. That's $21.7 million. 21 weeks with 280 workers is 280 people at $55 per hour at 40 hours a week at 21 weeks. That's $12.9 million. That is an $8.8 million difference. This ratio can be scaled for whatever size project we're talking about. The difference is in the man hours spent in waste because of a lack of flow. Pushing literally destroys projects, and our industry supers must protect us from this. One last point. Many supers will say, I've been doing this for over 30 years and have always finished on time. This is correct, but at what expense to the project, the owner, and the trades and their finances? It deserves a deeper look and further consideration. So I hope you've enjoyed this brief podcast today. I really want to make sure that we're making the point. Only flow will shorten durations. Only flow will decrease costs. Only flow will respect workers. Only flow will create balance for families. And that's why we're so focused on it. On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.